Bismillah wa salatu wa salam ala rasulillah. Welcome to General Chemistry with Dr. Zainab. Today we are going to solve recitation problems for chapter 2, which is about atoms, molecules, and ions. Please make sure that you have your periodic table next to you, but also the common monoatomic ions and polyatomic cations and anions. So let's start with exercise number 1. Calculate the density of a hydrogen nucleus and a hydrogen atom. So we're talking about hydrogen atom, and we have the mass of the proton, the mass of the neutron, the mass of the electron, as well as the radius for the nucleus and the hydrogen atom. So if you look in the periodic table for hydrogen, we have hydrogen 1, Z equal to 1, and the mass number equal to 1. So Z equal 1. So we have 1 proton. And A equal 1 means 0 neutron. So the mass of the nucleus will be equal to the mass of 1 proton, which is equal to 1.67 times 10 to the power minus 27 kilogram. And if you look, we have also electron, but the mass of the electron is equal to 9.11 times 10 to the power minus 31 kilogram. This is very, very small compared to the mass of a proton. So in our calculation, we will just consider the mass of the proton to calculate the density. So let's remind the formula for the density. D equal mass over volume. And here we have hydrogen atom, and we need to consider it as a sphere. So the volume will be equal to 4 over 3 pi r to the power 3. Okay, and we have the radius for the nucleus and the hydrogen atom. So we'll be able to calculate the density for both the nucleus and the atom. So let's go for D nucleus, which will be equal to M nucleus over volume nucleus, and which is equal to 1.67 times 10 to the power minus 27. It's in kilogram. We're going to have it in gram to have gram per centimeter cube. 4 over 3 pi. The radius here is 5, 10 to the power minus 14 cube, and centimeter cube, and gram on the top. And you can see also the significant figures. So here we have 3 significant figures, and 1, since it's a division, is going to have the smallest one significant figure. So it's going to be only 1 significant figure. And if you compute it, it's going to be 3 times 10 to the power 15 gram per centimeter cube. Okay, and similarly, we can calculate the density of the atom. It will be equal to the mass of the atom divided by the volume of the atom. And as I was saying, the mass of the atom, you should consider the mass of the proton, the neutron, and the electron. But the mass of the electron here is very, very small compared to the mass of the proton. And the hydrogen atom has no neutron. So the mass of the atom will be again equal to 1.67 times 10 to the power minus 27 times 10^3 for have it in gram, divided by the volume 4 over 3 pi. And the radius here is 1 times 10 to the power minus 8 cube centimeter cube. Again, you can see the significant figures. We have only 3 here and 1. So the results will have 1 significant figure. And if you compute it, it's going to be 0.4 gram per centimeter cube. So we can extend this exercise by, if I give you another atom, in that case, you need to consider the number of mass A and know how many neutrons you have to get that into account when you calculate the mass of the atom as well as the mass of the nucleus. Okay, so that was it for exercise number 1. If you look at exercise number 2, complete the following table, and we have the symbol, the number of proton, the number of neutron, the number of electron, and the net charge. Okay, here we need the periodic table, and for any element X, we'll have the number of protons Z and the mass number. And the relationship between them, the mass number A will be equal to the number of protons Z plus the number of neutrons N. Okay, and when it's charged, you're going to have X and Z A, and the charge will be equal to Z minus the number of the electron. Okay, Z is here, the number of the electron. So if the atom is positively charged, that means that it has loose electron. So Z will be bigger than the number of electron, and it will be positively charged. If it is negatively charged, it means that the atom has gained electrons, and Z minus the number of electrons will be negative. Okay, so the charge in naturally the atom is neutral, so Z is equal to the number of electrons, but it becomes charged when the Z is smaller or bigger than the number of electrons. Okay, so we'll use our periodic table to identify our elements and then solve the problem. So first one, we have the symbol. So we have that it's iron, so the Z is 26. Here it's going to be 26 for the number of protons. And we have the mass number A, which is equal to the number of proton plus N. So if you want N, it's going to be the mass number minus Z. So here 53 minus 26, going to be 27. And the number of electrons, since we have a net charge of 2 plus, we know that Z minus the number of electrons is equal to 2. Okay, so the number of electrons is 2. We have 2 less electrons than proton, so it's going to be 26 minus 2, 24. And here the net charge is 2 plus. For the second question, we still have Z equal to 26. So this is a property of the element. So we know that 26 is for iron. So going to be here iron, 26. To know the mass number, we know that the mass number A equal to the number of protons Z plus the number of neutrons. So 26 plus 33. And here is going to be 59. Okay, so this is the isotope for iron. We have iron 59 and iron 53. And here we know that the net charge is 3 plus. So we know that it's iron 3 plus. That means that we have 3 less electrons than the number of proton here. So if you compute Z minus the number of electron, it will be equal to 3. So the number of electron will be equal to Z 26 minus 3, 23. Okay. For the third row, we have Z. So if you look at our periodic table, Z equal to 13 is equivalent to aluminum. So we have aluminum 13. And we have the number of neutrons. So the mass number will be 13 plus 14, 27. And we know that the number of electrons is 10. So the charge is 13 minus 10, 3 plus. Okay. For the last one, we don't have Z, but we have the number of neutrons, and we have the number of electrons and the charge. So we know that the charge minus 2 equal to Z minus the number of electrons, which is 54. So that means that Z equal to 54 minus 2, which means 52. And if you look on the periodic table, the element with Z equal to 52, you have tellurium. So we have Te 52. The number of mass number A equal to 76 plus 52. And if you compute it, it's going to be 128. And the net charge is 2 minus. Okay, so you can solve easily this problem using the periodic table and how the relationship between A and Z, and also the relationship between the charge of the ion and the number of proton and electron. Okay, so that's it for exercise number 2. Now for exercise number 3, we have the atomic masses of lithium-6 and lithium-7 are 6.0151 AMU and 7.0160 AMU. And we need to calculate the natural abundances of these two isotopes. The average atomic mass of lithium is given is 6.941. So let's remind the formula to get the average atomic mass. So the average atomic mass here for lithium will be equal to the isotope, so lithium-6, the mass of lithium-6 times the abundance of or percentage of lithium-6 plus the mass of lithium-7 times the percentage or abundance of lithium-7 divided by 100. And by the way, if you look in the periodic table, lithium have the Z, which is equal to 3, and the mass number, which is equal to 7. Okay, so if you look on the periodic table, lithium is like this. So you can already put here 3. And for the other isotopes as well, 3. Okay. And what else do we know is the percentage of lithium-6 plus the percentage of lithium-7 will be equal to 100. So let's pose X equal to the abundance of lithium-6 and Y equal the percentage of lithium-7. So we know that X plus Y equal 100 and 6.941 equal X times 6.0151 plus Y times 7.0160 divided by 100. Okay, so we have an equation with 2 parameters. So we can get one way to solve it is just to give X equal 100 minus Y and put it inside this expression. And if you do that, you're going to get X, which is equal to the abundance of lithium-6, will be equal to 7.5. And Y, which is the abundance of lithium-7, 3 here, will be equal to 92.5. Okay, and as you can see, we have more of the isotopes lithium-7, because that's why the mass is actually very close to 7, and you can see here 6.941. And lithium is one of the only elements where the heaviest isotopes is the more abundant. So if you remember, we have carbon-12, we have carbon-13, we have also carbon-14. But the more abundant one is the lighter element, lighter one, which is carbon-12. If you look at hydrogen, for example, we have hydrogen-1, hydrogen-2, deuterium, hydrogen-3, tritium, and the more abundant one is the lighter one. But for lithium, we have lithium-6 and lithium-7, and the most abundant one is the heavier one, which is lithium-7. So you can remember this exception from the periodic table. If you look at exercise number 4, we have to name each of the following compound. So let's start by A. First, we need to determine if it's molecular or ionic. So the first one has H, C2, H3O2, and this part is an anion that is part of from your table that you should know, and it's come from H plus and the acetate anion. So this is acetate. So we replace the A by ic, so it's going to be acetic acid. If you look at B, here we have it's based on ammonium, so it's ionic. So we have NH4 plus, and NO2 minus. And this is the nitrite ion. So it's going to be simply ammonium nitrite. So for ionic compound like this one, you need just to know the name of the cation, the name of the anion. So here we have ammonium ion, nitrite, not nitrate, nitrite. Nitrite ion, and we put the name of the cation, the name of the anion, and we remove ions in between. So it becomes ammonium nitrite. For C, we have cobalt that can be 2 plus or 3 plus. And the sulfide anion is 2 minus. And if we look at the stoichiometry, you can see that it's based on cobalt 3. So we have cobalt, E, sulfide. If we look at C, it's a D is non-metal, is non-metal. So this is molecular. So how we name a molecular compound, keep the name of the first element, iodine. And for the second element, we replace the ending by I. So iodine, chloride. Okay. And for E, we have a metal and one of the anion that we should know. So this is lead. That can be 2 plus or 4 plus. And phosphate. So you should know this one, phosphate, 3 minus. And from the stoichiometry, 3 and 2 here from the formula, you know that it's based on lead 2. So it's going to be lead 2 phosphate. Okay, so we did A, B, C, D, and E. Let's go to F. So F is based on a metal and a non-metal, polyatomic anion, potassium, and IO3 minus, which is iodate. Very good. So here's going to be potassium, iodate. Okay. This is also ionic. If we look at G, this is H2SO4 based on H plus, so it's an acid, and SO4 2 minus, which is sulfate. Excellent. So it's going to be sulfuric acid. Okay. For H, it's again a metal and a non-metal. So based on strontium 2 plus and the nitrite and 3 minus. And we know that strontium has only one oxidation state possible. So it's going to be strontium nitrite. Okay, now I is based on aluminum 3 plus metal and a polyatomic anion SO3 2 minus, which is the sulfide. Excellent. So here's going to be aluminum sulfide. Okay, and for J, it's based on tin. It can be 2 plus or 4 plus. And O2 minus oxide. So from the stoichiometry, we know that it's based on tin 4 oxide. K is based on sodium and chromate. It's going to be simply sodium chromate. And the last one, this is one a little bit tricky, but I'm sure that you can do this one. H. So this is L. It's based on HCl. Okay, it's an acid, H plus, and ClO minus, which is the hypochlorite. Excellent. So for the acid, we keep the hypo and chlorus. So the ite is replaced by hypochlorous acid. So that's it for exercise number 4. Let's go to the last one, exercise number 5. So here we are going from the name to the formula. A, we have chromium 6, so chromium 6 plus, and oxide O2 minus, and we need to have this 3 times to balance the charge. Okay. For B, disulfur dichloride, so this is molecular disulfur S2 dichloride Cl2, and this is like this SS chloride, and it's not to be confused with sulfur dichloride. Okay, these two are different. For C, we have nickel 2 fluoride, so nickel 2 plus fluoride F minus, so the formula will be NiF2. For D, we have aluminum nitride, so aluminum ion and nitride ion. Formula is ALN. For E, nitrogen trihydride, so this is molecular. We have 1 nitrogen and 3 hydride, and this is also known as ammonia. The last one, F, ammonium sulfide. We know the ammonium ion, NH4 plus, sulfite, SO3, 2 minus. So the formula will be NH4, 2 times to balance the charge, SO3. Okay, so we need to know how to get from the name to the formula, as well as from the formula to the name. Okay, that's it for this recitation of chapter 2. See you again next time.